For example 6, it says, a window is in the shape of a rectangle surmounted by a semicircle, whose diameter is the length of the rectangle. If the perimeter of the window is 18 meters, determine the maximum area of the window to the nearest tenth. Well, what's this going to look like? I'm going to have a rectangle with a semicircle on top. Now, the diameter of the semicircle is the same as the length, which means that I would have a radius that is going to be half the length. So I'm going to let L be the length, W be the width, and R be the radius. And obviously the area here is going to be A. The length, the width, and the radius have to be positive, but they also have to be less than the perimeter. And the area also has to be positive. So if I'm solving for the max area, then it's going to be the area of the rectangle and the area of the semicircle, or 1/2 of the area of a circle. Now, we already know that the radius is half the length, and we know that the perimeter going around this is going to be one length, it's going to be two widths, and it's going to be half a circle, or pi times 1/2 the length. If the perimeter is 18, then I'm just going to try and isolate for one of the variables. And in this case, I'm going to isolate what W is. So if I'm isolating W, then I'm going to say that if I take 2W and move those lengths over, then I'm going to have 18 minus a length and minus pi over 2 times a length. When I divide by 2, I'm going to wind up getting 9 minus 1/2 a length, and then minus pi over 4 lengths. And I'm going to sub that back into my equation that we had. The area, which we're solving for the max of, is going to be the length times 9 minus half a length minus pi over 4 times the length. That is my rectangle. I'm also going to have that 1/2 pi r squared is going to give me 1/2 pi, and the length is 1/2 L squared. When I expand it all out, my area is going to equal 9L minus 1/2 L squared minus pi over 4L squared. And then when I take 1/2 times 1/2 squared, that's going to give me 1/8 times pi is pi over 8. And I'm still going to have that L squared. Well, both these terms have the pi and the L squared, so to make my life a little bit easier later, I'm just going to combine them. And I'm going to multiply the denominator here by 2 and the numerator here by 2, so I can actually combine those two terms. And I'm going to get 9L minus 1/2 L squared minus pi over 8 L squared when I combine those two terms. And now I'm going to derive. And A prime of L, when I derive this, is going to give me 9 minus L minus pi over 4L. When I go to my critical numbers, if 0 is equal to 9 minus L minus pi over 4L, then I'm going to move those L's to the left-hand side and get L minus pi over 4L is equal to 9. I'm going to remove a common factor of L, and I have 1 minus pi over 4. And I'm going to divide both sides by that 1 minus pi over 4. Because that's my only critical number, I'm going to use that for my first derivatives test. Now, I might want to put in my calculator and see what this is so that I could actually find something for there, because you're probably not going to know off the top of your head what 9 over 1 plus pi over 4 is going to be. So that's about 5.04. So when I have my points, I'm going to have 0. I'm going to have 9 over 1 minus pi over 4. And I'm going to have 18. When I pick my numbers, I'm probably going to do something like 1, like 10, and I'm going to see that A prime of L is going to be positive in this region, negative in this region, which means that A of L is going to be increasing and decreasing, and there's my max. Now, because this asked for the maximum area, I'm not going to go through and solve what the other side lengths are. I'm literally just going to put this in. A is equal to 9L minus 1/2 L squared minus pi over 8 L squared, or the area is equal to 9 times 9 over 1 plus pi over 4 minus 1/2 times 9 over 1 plus pi over 4 squared minus pi over 8 times 9 over 1 plus pi over 4 squared, which is going to give me 22.7 meters squared. Therefore, the largest possible area of the window is 22.7 meters squared.